Hello friends, I welcome you all in this session. In previous session we were discussing about how to calculate slake and floats, and we have seen different characteristics of those two important concepts, and we did solve one example also, and we calculated all those three floats. Now let us take one more example in which we will calculate the remaining float also, which is the safety float, right. So the example is like this. This is 3, event number 2, event 4, event 5, event 6 and event 7, and this event is the last event, right. So activity A is taking 10 days, activity B taking 8 days, activity 2 to 3 is a dummy activity, right. 3 to 4 is activity C is taking 9 days, 2 to 5 is activity E and this is taking 8 days, activity 4 to 6 is F, it's taking 3 days, activity 5 to 7 is activity H, it's taking 4 days, activity 4 to 7 is this, activity G, it's taking 8 days, this is a dummy activity, of course its duration is 0, right. And there is one more activity 2 to 4, this is activity D and it's taking 5. So A, B, C, D, E, F, G and H, right. So these are different activities. Now we will find out floats, right. So first of all let us calculate all T's and TL's, right. So TE at this point is 0, TE at this point is 8, TE at this point is 10, right. So if you go from this path, this would be 8, but we will take the longest one, right. Then you have got TE at this node is 8 plus 8, 16, 8 plus 5 is 13, 10 plus 9 is 19, right. When T is 19 at this node, TE at this node is 22, right. And TE at node number 7 would be, now there are several possibilities, right. 16 plus 4 20, 22 plus 0 22 and 19 plus 8 is 27. So TE is 27, right. Now after calculating all these T's, let us calculate TL's, is 27, right. So at this node TL would be 27, right. TL at this node would be 27 minus 3 is 24 and 27 minus 8 is 19. So TL would be 19 at this point, right. Now TL at this node would be simple, it's 27 minus 4 which is 23, right. Now TL at this node can be calculated from 3 sources, right. First this, second this and third is this, right. So 23 minus 8 is 15, 19 minus 5 14 and Okay, let us first calculate TL at this point. So TL would be 10 here, right? So now from here at this point, from this source, 23 minus 8 15, 19 minus 4 14, and 10 minus 0 is 10. So TL would be 10 at this node, right? And finally TL here would be, from this it would be plus 2, and from here it would be 0. So with this we have calculated all these TLs and TEs. Okay, let us recalculate TE at this point. Okay, so this is 8, and in fact there is one more dummy activity, 4 to 5. So when you have got this dummy activity, the TE value will change over here, right? And what would be the TE value? From here it is 16, from here it would be 19, right? So in fact it all depends on how these nodes are connected, right? In fact without dummy activity also the TE was all right, right? So now let us calculate all these floats, right? So the first of all select at all these nodes. At first node it is 0, second node 0, no, it's not 0, it is 2, right? At node 2 it is TL minus T is 2, right? At third node 0, fourth node 0, fifth node it is 4, right? Sixth node 0, and seventh node 0, right? Okay, at node 6, yeah, it's not 0, right? It is 5, yeah. It is 27 minus 22, right? So this is 5. So these are different slack values at all those nodes, right? So which are critical activities? You can easily identify 1 to 3, right? 1 to 3, 3 to 4, right? 4 to 7, right? Now let us calculate floats, right? So you have got total float, and these are different activities: A, B, C, D, E, F, G, and H, right? So total float for activity A, TL minus TE minus duration. So 10 minus 0 minus 10, this is 0. For activity B, TL minus TE, 10 minus 0 minus 8, so this is 2. For activity C is here, TL minus TE, right? TL minus TE, so 19 minus 10 minus 9, this is 0. At D, TL minus TE, right? So TL is 19, this is D, TL minus TE minus duration, so this is 6. At E, TL minus TE, so this 23 minus 8 minus 8, 16, right? So this 16, 23 minus 16 is 7, right? For F is here, right? TL minus TE, so 27 minus 19 minus 3, so this is 4, right? Activity G, TL minus TE is 27 minus 19 minus 8, so this is 0. H, TL minus TE, 27 minus 19 minus 4, this is this total is 23, so this is 4. So this is how you can calculate total float for all these activities, right? Now let us calculate free float. Free float, both T's, right? So T in free float you got TEJ and TEI, right? So T of succeeding activity and T of preceding activity, right? So let us look at this. So TE is 10 here, T is 0 here, right? So 10 minus 0 minus 10, so this is 0, right? For B, 8 minus 0 minus 8, this is 0, right? For activity C, this 19 minus 10 minus 9, this is 0, right? So we are focusing only on T's, right? So for activity C, T here and duration, right? For activity D is this, right? So T is 19 and T is 8 minus 5, 6, right? For free float of activity E, so this is 19 minus 8 minus 8, right? This is 3. For activity F is here, right? So this is 22 minus 19 minus 3, this is 0. For activity G, you got 27 minus 19 minus 8, so this is 0. For activity H, is 27 minus 19 minus 4, this is 4. Let us calculate independent float, IF, and IF is what? IF is this, TEJ minus TLI. So T of successor event and TL of preceding event, right? So TE minus TL, right? So TE minus TL. So for A, TE minus TL, this is 10 minus 0 minus 10, this is 0. Then TE minus TL, right? So this is 8 minus 0 minus 8. For C, again T minus TL, right? So 19 minus 10 minus 9, right? We'll write all these values after some time, right? So for example, okay, now for D activity, TE minus TL, so 19 minus 10 minus 5. For E is here, right? So TE minus TL, 19 minus 10 minus 8. For activity F, TE minus TL, so 22 minus 19 minus 3, right? Then for activity G, TE minus TL, so 27 minus 19 minus 8. And finally for H, it is TE minus TL, so 27 minus 23 minus 4, right? So this is 0, this is 0, this is 4, this is 1, this is 0, this is 0, and this is also 0, right? Let us calculate safety float. Safety float is what? TLJ, TLI, right? So we will take only latest times, right? So for activity A, 10 minus 0 minus 10. For activity B, 10 minus 0 minus 8. For activity C, 19 minus 10 minus 9, right? For activity D, you got 19 minus 10 minus 5, right? For activity E is here, right? So 23 minus 10 minus 8. For activity F, it is 27 minus 19 minus 3. Then for G, it is 27 minus 19 minus 8, and finally for activity H, it is 27 minus 23 minus 4. So this is 0, this is 2, this is 0, this is 4, this is 5, right? This is 5, this is 19 and 8, this is 27, so this is again 0, right? This is also 0. Now this is how you can calculate safety float. Now if you look at independent float and safety float, you are having safety float values more than independent float values. It means we can say that safety float values cannot be less than independent float's value, because this is the shortest float amongst all these 4 floats, right? So this is how you can calculate floats for a given network, right? Let us move on to couple of limitations of networks. In fact, we have made several assumptions when we were drawing networks. One of the assumption is that no activity can be repeated, but it happens several times in a project that you do repeat activities, right? So that is a kind of limitation of network. The second problem is that all immediate, in fact we assume that we will start this succeeding activity once all the preceding activities are finished. Now this is quite an unrealistic assumption. In real life you can have different situations. It is possible that, let us say for a project in which there are 3 preceding activities and 1 succeeding activity. Now it is possible that you have started all the preceding activities, and after 1 week of starting of all those 3 preceding activities, you may start succeeding activity. It is possible, right? And we have seen a case of laddering, right? In fact, wherein we did break an activity into sub activities, right? So that is what you can say, that you can resolve this particular limitation using laddering, right? So at times, even after completion of few preceding activities, the later activities can start and go concurrently, right? Now it is possible, especially in PERT network, that if there is a critical path, then you may have a situation where the difference between critical path and non-critical path is very small, and that non-critical path may become critical if you change the time estimates. So let us take an example to understand this point. So let us say you have got a network like this. Right, and there are 3 activities, A, B and C, and their time estimates are 3, 5 and 7. 3, 5 and 7. For this it is 2, 5 and 8, and for this it is 6, 9, 12. Now which path is critical path? Let us look at this. It is like this. Since this is a PERT network, you need to calculate expected value, right? So this is 3 plus 7, 10 plus 5 into 4, right? So this is 30 divided by 6. So 5 would be the expected time for this, right? TE is 5. TE for this would be 5. This 2 plus 8, 10 plus 20, 30 by 6 is 5, right? Similarly here it is 18 plus 36. 18 plus 36 divided by 6, so that would be 9. So critical path is this path, right? But let's say there is a situation where you may have a situation where you are completing these two activities at their optimistic times, but you are completing this activity at its expected time, right? In that case the critical path will change. When I say when these two activities are completing at their optimistic time, it means 3 and 2. So this is 5 and this is 9. In fact, if you take optimistic times of all these 3 activities, then in that case this path would become critical path, not this path. So whenever there is little change, there is possibility of change in critical path. So this is another drawback, right? As I said that activity generally takes beta distribution, but if it does not take beta distribution, then you will have a problem, right? And if the situation is uncertain, then it is good to simulate duration of the activity. In one of the very important assumptions in network is that you will have only one ending node. Now that is true if you are successfully completing the project, but in reality you do not complete all 100% projects in time, right? You will have many projects leaving in between. In those situations you will have several ending events. So in case of partial success you will have several ending events. So let me summarize before starting for a time and cost relationship. In fact, I would like to summarize, especially we have talked about probability issues in networks. So we did calculate what would be the total probability of completion of a project within a given particular time. We can do one more thing. In the examples which we have seen, what we did, we have calculated that what is the probability of completing this project in this much time. Vice versa can also be done. You may be given probability and you will have to calculate the completion time. For example, if I say, let us say the TE of the last node in a network is, let us say, 30. T is 30, it means its expected time is 30. So project would be completed in 30 days, its probability is 50%. Now I may ask you a question: if the probability of completing a project is 60%, then how many days it will take? A completely different question. Though we didn't work out a question like this, but you can always come up with such questions. Then we have seen, of course, simulation of activities, and it was quite a hectic task, but since you have got computers, you can write a program and you can simulate duration of an activity thousands of times, so that you will have a precise time estimate. In today's session we have seen a couple of important points related to slack, float, and different limitations of network techniques, and these floats also. So with this, let me complete this particular session here itself. In next session we will discuss something called time and cost relationship, which is again an important knowledge area of project management. So to give you an idea about next topic, you have got cost, right? Whenever you do a project, you need to involve costs, and there are different types of costs, and there is a relationship between time and cost, and this relationship is generally inverse relationship. So when you increase the cost, it depends. Again, I won't say that there is only inverse relationship or direct relationship. It depends on situation, and it depends on cost also, what cost you are talking about. Generally it happens that whenever you increase the length of a project, cost also increases, right? And we will see this topic in detail in next session. So with this, let me complete this session here itself. Thank you very much.